Hey guys, welcome. Yeah, so how do terrorists do it? No, silly, not integrals. I mean, like, wear masks and be in the desert. Like, I'm sweating, I'm dying. Okay, with that said, in this video, I'm going to show you how to use the same approach that we used on the integral of x to the x to do these two integrals and integrals of a similar variety to these two. And this is what I mean by similar variety. Consider x to the power alpha times x to the power beta. Then, when alpha is equal to a half and beta is equal to 1, we get this integral. Well, so long as we put an integral sign. And when alpha is equal to 1 and beta is equal to a half, we get this integral. So let's find the general result. And of course, you can make other choices of alpha and beta besides 1 and 1/2 and 1/2 and 1. And so you'll be able to get integrals of a similar variety to these two, or seeing how to solve those types of integrals. Okay, now first notice that this here is equal to e to the alpha times x to the power beta times the natural log of x. And then using the series expansion for e, we see that this is the same as, it's equal to n equals 0 to infinity, and then alpha to the n, x to the beta to the n, and then natural log of x to the n, all divided by n factorial, right? Okay, cool. So then, if I do this, I must do this, and do this. Next, let's make the following substitution. Let's let negative natural log of x equal u. Then that means that the natural log of x is equal to negative u. And that means that x is equal to e to the negative u. Furthermore, from here or there, we get that negative 1 over x dx is equal to du, which implies that negative x du is equal to dx, but x is e to the minus u, so negative e to the minus u du is equal to dx. So then, picking up where we left off, which is right here, we can write over here that what we have is the same as, and we could put alpha to the n outside of the integral, right? As well as the n factorial, but inside of sigma, very important. And then we have integral. Notice this substitution, negative ln of x equaling u means that u is equal to the natural log of 1 over x. So when x is equal to 0, we get u is equal to the natural log of 1 over 0. Natural log of infinity, which is infinity. So since we're switching to u, 0 turns to infinity, and then 1 turns into natural log of 1 over 1, natural log of 1, which is 0. Yeah? Okay, cool. And then x to the beta, x to the beta, right, is going to be e to the minus u to the beta. So e to the minus u to the beta, but then this in turn, x to the beta is raised to the power n. So we have all of this to the power n, right? But that's cumbersome. We could just write beta times n, right? So beta times n. Got it. And then now we're on to this. That's minus u to the power n, which is the same as minus 1 to the power n and then u to the power n, right? And I actually have room to write alpha to the power n and then minus 1 to the power n here, because I'm not sure I have room here. So let's just write the u to the n here. Yeah? Okay. And of course, the last thing to replace is a dx, and dx is right here. First, the minus sign from dx is going to allow us to write these guys to be somewhat normal, 0 to infinity instead, right? Okay? And then the rest of dx is e to the minus u du. Now I saw e to the minus u elsewhere, and that is right here, right? And it's to the power beta n, and here is to the power 1, right? So if we combine them, we could just write beta n plus 1 on e to the minus u here. That way I could just write du at the end here, yeah? Okay, cool. All right, where to from here? Well, e to the minus u to the power beta n plus 1 is the same as e to the minus u times beta n plus 1. So I'll write that. So e to the minus u times beta n plus 1. Okay, and then one more substitution will set us free. U to the n, and then du is what we had. Okay, and that one more substitution is going to be like this. So let's let t equal t be negative, no, not negative, sorry. Let's let t be u times beta n plus 1. So t is all of this except for the minus sign that I accidentally just went over. So we had a minus sign right there, right? So t is this here. Okay, just making it clear. So first, dt is going to equal beta n plus 1 du. So dt divided by beta n plus 1 is equal to du, and then t divided by beta n plus 1 is equal to u, right? And that should be all the substitutions required to move forward. So I'll again write in red, picking up from here. So what we have now is the same as n equals 0 to infinity alpha to the n negative 1 to the n over n factorial. And then we have integral. Notice that the limits of integration do not change, because when u is 0, t is going to be 0, and when u goes to infinity, t will also go to infinity. So we still have 0 to infinity, and then we have e to now minus t, right? E to the minus t, and u to the n is going to become t to the n divided by beta n plus 1 to the n. So that's t to the n divided by beta n plus 1 to the n, right? Okay, that's u to the n. And then du is dt divided by beta n plus 1. But I already have a beta n plus 1 right here. So multiplying this by beta n plus 1, that is the same as just going plus 1 like that. Yeah? Okay, so almost done. So now we see that what we have is the same as n equals 0 to infinity of and then I could write the beta n plus 1 to the n plus 1 right here, and then I simply have, behind that, I guess I'll do it in a different color, integral 0 to infinity, and then e to the minus t, and times t to the n dt. Right? Okay, now I made a bunch of videos on the gamma function. So this here is gamma of n plus 1. What I wrote in blue here is gamma of n plus 1. So we go gamma of n plus 1. But then in videos I show that gamma of n plus 1 is simply n factorial. So I could just write n factorial right here. Yeah? Okay, cool. So what can we do? Well, I have an n factorial here, an n factorial there. And so our final answer is this here. Notice that when alpha and beta, and our original construction was looking at x to the alpha times beta, alpha x to the alpha times x to the beta is what we looked at. So when alpha and beta are both equal to 1, then we get the x to the x integral result, as you should see, because this would be 1 when alpha is 1, and then here we just get n plus 1 to the power n plus 1. Otherwise, in the numerator, -1 to the n equals 0 to infinity. That's what we found to be the answer for the integral of x to the x. So here we found the general result, and so obviously, like, if you want to solve this integral, choose alpha to be 1/2 and beta to be 1 in here. And then if you want to solve this, choose alpha to be 1 and beta to be 1/2 in here, and so on. Yeah? Okay, cool. I hope you enjoyed this, and keep watching. Take care.